Hello, my name is Dr. David Harvie. I'm from the College of Aviation, and today I'll be talking on applying peer-led team learning in online engineering courses. So this research is made possible through the grant by the National Science Foundation, the engagement of non-traditional students in engineering pathways. The grant was from 2022 to 2025. Dr. Kimberly Luthi is the primary investigator. Co-PI is Dr. Keith Wilson and Dr. Monica Surrency and myself. So, what's our research plan here? Well, peer-led team learning, what is it? Well, it's a collaborative learning intervention that's been primarily applied in brick and mortar institutions. So you have a student that's been successful in a class, and they get recruited to be a peer leader for another instance of that class, and they can help answer questions, be involved with activities with the students that are taking that class in order to help reinforce concepts that may be difficult, to answer questions. It's another support mechanism that the students may feel more comfortable reaching out to a peer that has taken the class just one semester or term before. Then they may be reaching out to the instructor. And in the brick and mortar institutions, they've shown that there's demonstrated improvement in both student performance and persistence in engineering disciplines. And so our research hypothesis is how can we apply this peer-led team learning in support of foundational engineering courses. That if we do that, this will lead to a greater persistence in the students completing those engineering disciplines. So we first had to figure out what are some of those foundational online engineering courses, and the ones that we initially identified were aerodynamics, digital circuit design, and statics. So with that being said, we then need to recruit and train peer leaders. So we looked at who had done successful in those courses, who had got A's or B's and recently completed it. We sent out recruiting emails and for those that responded positively, then we had them go through a 10-hour self-paced course where they learned about their learning styles and other various types of learning styles. How do you communicate effectively, especially in an online environment? And how do you provide effective feedback on an activity in Canvas? And so their task would be to provide feedback on specific peer-led activities to their assigned students. Typically, that's about 3 per course. They'd be assigned, the goal would be about 6 students per peer leader, so it would not be too large so that they feel more comfortable in communication. They'd hold weekly 1-hour virtual office hours for those students. And for most of them, they also would do a weekly 1-hour introduction or talk about that module that the students were going through, just to help reinforce the concepts that the instructor is covering and maybe identify some of those areas that may be kind of tricky. So just once again, they're not teaching the material, they're helping to reinforce the concepts that are being covered by the instructor. So as mentioned before, typically looking at 3 activities per course. And so these activities are going to be taking assignments that students have struggled with before, and then having to modify those assignments so that way we can put them like in most often in the type of discussion board. Give an opportunity for students not just to answer the question, but to show their thinking, to allow the peer leader to understand what their train of thought is, and then provide feedback to the student. The goal is not to say, hey, here's the right answer or the wrong answer. No, it's more of, do you understand the concepts? Are you solving the problem the correct way? And if they are, it's a reinforcement that yes, they're on the right track. If they're not, well, is there a way they can kind of nudge them and make them thinking about how to correctly approach and solve the problem? And initially, these activities were additional. We were added on to the curriculum. But as you'll see through our findings here, we actually made these activities incorporated into the course assignments. So we started in academic year 2022-23. The fall of that year was spent developing the activities, building the training for the peer leaders, and then in recruiting them and training them. So we piloted our first section that had peer-led team learning in January of 2023 in digital circuit design, and then we expanded that pilot to 3 sections in March. So another section of digital circuits, but we also added aerodynamics and statics. Now, these activities were not mandatory, but we incentivized them with the offering of extra credit. So the idea that, hey, if you participate in these activities, it'll be beneficial for you, and this will help. Even though they're incentivized, you'll see that we had a very low participation rate, just 12%. And as we did our analysis, okay, why wasn't more people take advantage of this opportunity? It goes back to our student base. Most are adult learners, so they have jobs, responsibilities. Maybe they have families. There's time is something that they do not have a lot of, and so if you say an activity is optional in a course, most of them will say, "I'm not doing it. I just don't have the time." So that forces us to go back and for year 2 to see if we want them to do these activities, we need to move it from being optional to being mandatory. Now, as we made that change over the summer, we could not make this officially part of the curriculum. So they were mandatory, but it wasn't part of the grading. Not yet. What this did do is that mandating participation activities, we could specify sections that were to use peer-led team learning and compare them to sections without that peer-led team learning. And so this kind of gives us that experimental control types of groups. And for those that are in the peer-led team learning, we put an assessment bait for the instructors to see in the peer leaders, did they do high effort, low effort, medium, or just none? So that way we can have an idea of, how much involvement did the students have? Did it have an effect? And we did see. So here is an example of aerodynamics from August of 2023. It's interesting that overall, you'll see that for the experimental and the control sections, really the student average was almost identical. But as we looked into the efforts into the peer-led team learning, we do see that for those that put a high effort or at least a medium, they did better than the student average and much better for those with a low effort. During the spring terms, we were able to get these peer-led team activities to be designed to be part of the graded assessments. So for those sections, this is now, it's graded, it's fully incorporated, be easier on the students. You'll see that we expanded to include fluid dynamics in March of 2024. And at the end of the year, we had 8 peer-led team learning sections with an enrollment of 196 students. Going into year 3, this is where we scaled it up as far as the number of sections, the number of peer leaders, and we did by a factor of 2. So 7 sections incorporating peer-led team learning. We got aerodynamics, digital circuits design, fluid dynamics, statics, and overall enrollment of 154 students. So we have more students in these 2 terms than we had in the previous 4 terms. So we doubled it. And as we looked at the overall averages, we saw that they were statistically the same. And as an example here, digital circuits in August of 2024, really hard to, and also statics, it's they're very close. So it looks like at least we are, there's not a clear differentiation. And so one of the things that we're looking at then is, all right, what about persistence? And so that's what this year we started to look at, the exploration of persistence engineering pathways. So as that first cohort that went through our pilot studies, just over really 3 years ago, now they'd be going into their senior year, we can look at, are they still in those pathways? And in the specific pathways was the Bachelor of Science of Engineering and Bachelor of Science of Engineering Technology. And so our future research is to look at those up-level courses, and the ones that we specifically look at are mechatronics, systems control, and systems and signals. And that's something that we are still doing as part of our extended research. Now, this research is not without its challenges. And just to kind of talk about how hard it is to recruit peer leaders. There's a very condensed timeline to identify, recruit, hire, and onboard a peer leader. How do you identify? Well, you look for students that did well in a course. Well, if someone did very well in, say, the August term, is there enough time to recruit them to teach, be a peer leader for October? Unless you've done it very early in the August term, there's not. And even to get them ready, so say like the January term, you've got to get them identified. They got to be hired. So you're going through the HR process of onboarding, and then we got to get them through the training. So, with the way that our modules are set up, this is a challenge, and it always will be a challenge. Especially, not only have to recruit, but you have to continuously recruit because our great peer leaders do graduate and they move on. Going back to the HR challenges, one of the things that as we went through this and we're recruiting peer leaders from worldwide is that with the hiring, we now have to hire students that they must live in either Florida or Arizona. And so that impacted some of our students that, say, lived in Pennsylvania or other states. And so that's a challenge that we have to now, have to deal with. Recruiting peer leaders from the worldwide campus is challenging because, once again, that student base is a lot of adult learners with limited time. So if you have people it's hard to do a peer-led team learning activity, it's really hard to say, I have time to be a peer leader. And so what we did is look to recruit resident peer leaders, to look at the Daytona Beach and Prescott campuses, of students who have taken those classes as part of worldwide. So if they've taken, they've experienced with worldwide courses, and so they've done well, did well in statics or in say, digital circuit design, they can apply that and help be peer leaders for worldwide students because they have previous experience with the worldwide environment. And so what's some of our future work? So we're still doing analyzing the student performance for this academic year. Obviously, National Science Foundation had funding issues, and right now, our peer-led team learning activities stopped during the spring terms. And for those that are on NSF grants, you know that what that means. And so we have the data that we have now. We're going to analyze the student persistence engineering pathways. We do plan to pursue a follow-on NSF grant to expand this peer-led team learning concept further in the college and in worldwide, and to continue this research. So it's very exciting. We see some. I think one of the things that we would look at in the future is not just the benefit to the students that are getting the benefit of a peer leader, but how much the benefit is for the peer leader. Look at that, the experience of the training that they have and the experience of them having to help communicate, and provide feedback. So that's one of the things as we look forward is to look at that part of the equation. So I know that this is a recording, so they may have a chance for any questions, but if you do, please, you see my email here. Please reach out to me, and if this is of interest to you, we would love to answer your questions and see if there's anything that we can do to help collaborate. Thank you very much for your time.